All right, 10.3. We are defining and using probability of single events. 10.4 is multiple events. So we're just looking at probability today, so let's define it. Probability is used to measure the chance of an event occurring. A desired outcome is called a success. Everything else is considered a failure. I know. So, basic probability of a single event, meaning we're just looking at one specific event, we're not looking at multiple events at once, is the probability of your desired outcome, that's what the parentheses means, all successful outcomes over all possible outcomes. Basic probability, what we learned in elementary school. So we're going to have dice problems, card problems, and like marbles in a bag problems, those kinds of things. A couple of things you need to know about probability. We do have some rules of probability. I'm going to highlight that. Okay, rules of probability. Probability is expressed as a fraction, and a fraction means that the event must be between 0 and 1. So you should never have an improper fraction. You should always have 1 over 6, 2 over 5, 3 over 4. You should never have a bigger number on the numerator than in the denominator. It always should be between 0 and 1. Same thing, you should never have, meaning you should never have a negative probability. Probability is always between 0 and 1. Can it be 1 or 0?
Yeah.
Yes, it can. If probability is 0, that is called an impossible event. An example of an impossible event. Say I am spinning a spinner, and there's 3 colors on the spinner, white, black, and green. What is the probability of spinning blue? 0, because it's not even on the spinner, right? So it's an impossible event. There's no way it can possibly happen. The probability of a certain event is going to be 1. So let's say I give you a different spinner and there's only 1 color on it and it's green. What's the probability that I'm going to spin a green? 100%, or 1, right? Because it's always going to come up green. Make sense? Okay. When you are adding up all possible probabilities, or all possible outcomes, your probability should always come out to 1. So the example I use is a 6-sided dice. If I'm rolling a dice, what is the probability of rolling a 1? 1 out of 6, right? Now that's not all possible outcomes, is it? No, what's another outcome? Rolling a 2. What's the probability of rolling a 2? 1 out of 6. What's the probability of rolling a 3? 1 out of 6. You guys get the idea? A 4 is 1 out of 6. Probability of rolling a 5 is 1 out of 6. And the probability of rolling a 6 is 1 out of 6. Are those all possible probabilities on a dice? If I added all of these 1 6 together, what would I get?
1.
6 over 6, which reduces to 1. So if you take all possible probabilities for a certain event and add them up, it should always add up to 1. Okay? Last rule of probability is called the complement. I'm going to define this for you in the next set of notes. What you need to know is the complement means the opposite of something. So, for example, the complement of flipping a coin heads, what's the complement of that? Tails. If I am trying to roll a 6 on a dice, the complement would be any number but 6. So anything except what you want to happen. You subtract 1 from that event happening. Okay? Because they always should add up to 1 like we showed in the first one. So if you subtract the probability of the event from 1, that will give you the complement. All of the outcomes except the one you want. Okay? So let's look at some basic probabilities. We're going to roll a dice. Or a die by itself. A die means 1 dice by itself. Dice is actually more than 1. Die is the singular.
Wow.
I know you guys learned something new.
That's interesting.
Okay.
That's noteworthy.
So, what is the probability of rolling a 5? 1 out of 6. Easy. What is the probability of rolling a number less than 3? What numbers?
1/3.
What numbers are less than 3? 1 and 2. So there's 2 out of 6, and you do want to reduce that to 1/3. So with probability, after you're done manipulating the fractions in the ways that I'm going to show you, you always want to reduce as much as possible in the end. Okay, so your fraction should always be reduced. What about the probability of getting a number less than 13?
100%.
100%, that's 6 out of 6, right? Which reduces to 1. What's the probability of getting a number greater than 0?
0.
There are no numbers, greater than 6. There are no numbers greater than 6, so our probability is 0. What was the first one called? A certain event. If it's not possible for the event to occur like in D, what is that called? Impossible event. I'm just labeling them for you now on your homework and the test. If this comes up, you don't have to label them, but I want you having it labeled just so you have an example of each one. Okay, now the complement of getting a 5. Our complement, remember, means that you're going to subtract 1 minus the probability of the event because the word complement is in there. So this is going to be 1 minus the probability of rolling a 5. What's the probability of rolling a 5? 1 out of 6. So we need to actually do this. I can rewrite 1 as 6 over 6, yes? So 6 over 6 minus 1 over 6 gives me 5 over 6. Doesn't that make sense?
No.
Yes.
How many numbers are possible if I do not want to roll a 5?
Oh, I had that.
1, 2, 3, 4, 6. So there's 5 of them. So the probability of not rolling a 5 is 5 out of 6. Make sense? That's what complement means. Not coming up with what they want. Okay? Okay, example 2 has to do with decks of cards. So there's a couple things we need to talk about decks of cards because not everybody knows this. First of all, how many cards are in a standard deck, which means you are not including the jokers. 52 cards. So there's 52 cards in a deck. I want you guys to write these down so that you have it written down somewhere.
So there's really 54 in a deck.
If there are jokers, there's 54, but you don't count them as part of a standard deck. How many suits are in a deck of cards?
4.
4 suits. What are they?
Hearts.
Hearts, diamonds, spades. This one's the hardest one for me to draw. I don't know. Spades and clubs, right? That's a clover. Not bad. I did better last time. How many, the spades is not very good. How many of each number are in each suit? How many numbers are in each suit? 13. Ace, 2, 3, 4, all the way to Jack, Queen, King comes out to 13 cards in each suit. It's a spade. I'm going to stop trying. I did better on the last one. Okay? So we have 4 suits, 13 cards in each suit, all comes out to 52 cards total. So now let's look at our examples. Example 2, we are drawing 1 card from an ordinary deck.
How is that 13?
Okay, so from an ordinary deck, we're always going to be dealing with an ordinary deck, meaning no jokers. So I want to know the probability of drawing a jack if I'm just drawing 1 card. How many jacks are there in a deck of cards?
4.
There's 4 of them, so your probability is going to be 4 over 52. Now that does reduce to 1 over 13. So you have a 1 in 13 chance of drawing a jack. What is the probability of drawing a 6 of clubs? How many 6 of clubs are there?
1.
Just 1, so it's 1 out of 52. Okay, Part C, the probability of drawing a diamond. How many diamonds are there? 13. So that's going to be 13 out of 52, which reduces to 1/4. And does that make sense? There's 4 suits, and we're just looking for one of them?
Yep.
Okay, what about the probability of drawing a black card? How many cards in the deck are black?
26.
26 out of 52, which reduces to 1/2. Spades and clubs are black, hearts and diamonds are red. Okay?
I haven't played
Makes
cards in a
sense?
while.
You guys good with cards?
Yeah.
Okay, so let's look at our last one, example, which is marbles. I have a bag and it contains some marbles. There are 6 white marbles, 3 blue marbles, and 7 green marbles. How many total is that? 16. So with these types of problems, I always write the total so I don't have to keep adding it up or memorize how many are in my bag. So what is the probability that the marble is white? How many white marbles are there? Good, 6 out of 16. Now that does reduce by 2 to 3/8.
Almost 1/2.
Okay, so now we're looking at the probability that the marble is not green. How many marbles are not green? 9 out of 16. So the 6 white and 3 blue add up to 9/16. That does not reduce. What about the probability that the marble is blue or green? So let's look at blue first. What's the probability that the marble is blue? 3 out of 16. And what's the probability that the marble is green? 7 out of 16. So that comes out to 10/16, which does reduce to 5/8. That is probability of a single event.
That's it?
That's it.